Today we are going to finish 3-7. We will be using determinants to solve a system of equations. So what we're going to do is, if you have a system of equations, I want you to make sure that it's written with x and y on one side and then it equals your variable on the other for both of them. And then you're going to make what we're going to call a coefficient matrix. So coefficient matrix is going to have the coefficients like so. A, B, okay, and then over there. So if I'm doing 4A, that coefficient matrix would be 7, 3, and then -5, -7 because of that minus sign there. That's literally all I'm doing to start with. Let's go ahead and find the determinant of that. So I'm going to be calling that my coefficient determinant. And so it would be 7 times -7, which is -49. And then I subtract 3 times -5, which is -15. That's a double negative. And I should get -34 if I recall. Go ahead and let's label that to make sure that it's labeled. So what I'm going to do next, if I want to know the x variable, I'm gonna call it the x matrix. What you're going to do is actually take what it equals, the mn as they call it up here. Highlight that where you can see it, okay? You're going to plug those in for the x column, right? Like the x coefficients. So what I'm going to do here, instead of writing 7, -5, I'm going to write 37 and -41. And then just finish out your matrix with 3 and -7. Now I'm going to go ahead and determine my determinant from that. So 37 times -7, I've already worked the math out with a calculator, so it's -259. And I'll be subtracting 3 times -41, which is -123. 1, 2, 3. Double negative, add them together, and I get -136. So if I want to do the y matrix, this time what I'm going to do is replace the y coefficients with that m and n. So check it out. First I start with 7 and -5, but now I'm going to put 37 and -41. Find the determinant of that. So do 7 times -41 is -287 minus 37 times a -5 is a -185. Double negative makes positive. So if I add those together, I get -102. Okay, so I found my different matrices. You're going to have 3 different ones. Set up your matrices, find the determinant. So now we're going to do the division. And here's what you do for that. And it's written up here. What you're going to do is you're going to take the number you found. So for the x variable, take the number you found, -136, and you're going to divide that determinant by your coefficient matrix determinant. That was this thing right here. So I'm going to divide by -34. And a negative divided by a negative is a positive, and you actually just get a nice happy 4. That means x equals 4. Then you can do the same thing with the y to find the y. So I'm going to do my -102 divided by -34. Again, you divide it by the coefficient matrix, and you should get a negative divided by a negative, and it's 3. It's a weird 3. That means y is 3. So if I want to write my answer as a point, x is 4 and y is 3. It's kind of a long way to do it, but it always works. So it's pretty cool that way. I'm going to pass on doing another example, although I am going to show you that you can do it for a system of 3 equations. So if you remember that kind of awful section that we did, that I only gave you like 2 or 3 problems to do on your own, you can use, we call this Cramer's rule. I forgot to tell you that. This is called Cramer's rule. You can use Cramer's rule to solve a system of 3 equations. Your coefficient matrix would be 3, 5, 2, -4, 3, -5, 5, 4, -7. Okay, so if I wanted to find the x variable, this is like my x column, my y column, my z column. So if I want to find the x column, or the x variable, I would replace the x column with that answer column, right? And then 5, 3, 4, 2, -5, -7. I would do the same thing then for the y and the z, right? Find those determinants. Remember, finding a 3 by 3 determinant kind of takes a while. Then I would do that division each time, and that's how I could get the answer. It's tedious and it takes forever, but this is my personally preferred way to solve a 3 by 3 matrix. So, all right, we are going to call it a day right there.